So, let me explain this. The broader objective of econometric analysis is drawing inferences about population. Let us say that this is my entire population. This is my entire population consisting of several individuals. This is my population, okay? This is my population. This is my population. So, I want to study the consumption behavior of this particular population. Let us say that we are talking about the consumption behavior of the entire Tamil Nadu. And what is the consumption behavior? The consumption behavior, what we have previously mentioned, we will study how the people in Tamil Nadu they behave when their income changes. Okay, as income changes, what is the additional change that these individuals in the population of Tamil Nadu they make in their consumption? But what we will do, we will not go to each and every individual of Tamil Nadu, because there are so many individuals residing in Tamil Nadu, and it is actually not possible to go to each and every individual and collect data, right? That is a very time consuming and costly affair. Rather, what we will do, we will collect a sample from this population. Let us say that I have collected a sample of 1000 individuals from this population. Okay. So, this is my sample. So, that means if you think about, by observing this sample, we will collect this sample and then we will analyze, we will apply econometric tool on this sample, and then we will try to infer something about the population. This is about inference. Inference making. Okay. So, we will have a population in this particular context. As an example, let us assume that the entire Tamil Nadu is our population. From that particular population, we have collected a sample of, let us say, 1000 individuals. Okay. Then we will apply econometric tools on the sample, and then we will try to infer something about the population. Okay. This is basically the first objective of econometric analysis. So, in terms of the population, what is the particular econometric model that we have specified? Yi equals to alpha plus beta xi plus ui. Okay. Now, look at earlier when you were talking about mathematicians' objective and mathematical models, we were talking about only yi equals to alpha plus beta xi. We never introduced this ui term there. Now, here I have introduced the error term as well, which is ui, and this error term basically captures the other important variables which are not included in my model, but they are also having some kind of impact on your consumption. And it is very easy to understand that apart from income there might be many other variables that might have some impact on your consumption. Maybe your gender, whether you are a male or female, maybe your taste and preference, maybe your age, maybe your education, so on and so forth. So, all these variables are not included in the model. Even though you include all those variables in the model, consumption is basically a human behavior. Human beings, they do not behave like a computer. So, even if you know somebody's income, somebody's consumption, somebody's age, somebody's education, it is very difficult to predict exactly what will be the individual's consumption. That is why before conducting econometric analysis, we convert the mathematical model into a statistical one by adding this stochastic error term. Okay? This error term ui basically captures the influence of other variables, other omitted variables on the consumption. Okay? So, we will specify this model, and then what we will do, we will collect the sample, and from the sample we will estimate alpha hat and beta hat from the sample. So, from the sample we will get alpha hat and beta hat, and using this alpha hat and beta hat, what we will do, we will try to infer something about the true population parameter. Okay? So, our true population parameter is alpha and beta, because that represent alpha beta basically explains the structure of the population. That means, they explain the behavior in the population. They are actually unknown population parameter, and the sample counterpart of those population parameter are known as sample statistic. So, the objective of the entire econometric analysis is basically drawing inferences about the true population parameter alpha and beta from the sample statistic alpha hat and beta hat. This is the first objective of econometric analysis, which is drawing inferences about the population. And how we will do this is, this particular figure explains how we actually do about it. We have a population, we collect a sample, and then we estimate the econometric model using econometric tools. And how will you estimate that, I will explain in a later part of our discussion. Once you estimate, you will get alpha hat and beta hat. They are basically the sample counterpart of the true population parameter. Then using this alpha hat and beta hat, we will draw some inferences about alpha and beta, the unknown population parameter, and our objective is to, we will estimate alpha hat and beta hat in such a way that alpha hat and beta hat is as close as possible to the true population parameter alpha and beta. Okay? So, this is the first objective of an econometric analysis. This is the first objective. Then what is the second objective? Second objective is estimating a causal relationship between the dependent and independent variables. Here I am using two new terms, dependent and independent variable. So, in our example, when we are talking about the consumption income relationship, consumption is called the dependent variable because that is dependent on somebody's income. Okay? We are assuming that consumption is a dependent variable and income is the independent variable. In this model, this is a very simplistic model, we have included only one variable. So, that is why it is called a simple two variable model. And then what we are trying to establish, a causal relationship between income and consumption. Now, we have to keep one thing in mind. If you recall, initially we mentioned that econometrician's role is like an artist. So, here you assume econometric analysis per se will not tell you what should be the dependent variable and what should be the independent variable. That should come purely from your own understanding or from the existing theory, right? From the existing theory. So, when you are trying to formulate the econometric model, then you have to take help from the existing literature, or you have to apply your own logic to decide among these two variables between income and consumption, what should be the dependent variable and what should be my independent variable. So, when you are thinking income as a independent variable, it is very easy to establish the link between income and consumption, because generally it is income that leads to somebody's consumption. But is it possible to think in another way? Can consumption also lead to income? Apparently, you may think, no, it is not possible. It is only income that should lead to consumption. But how consumption will also lead to income? Yes, it is possible. For that, probably what we should do, we should we should we should think about one macroeconomic identity. If you are aware of national income identity, where y is basically equals to c plus I plus g. C is consumption expenditure, I is investment expenditure, G is the government expenditure. Now in this, see here consumption is basically leading to income. So that means at the macro level, consumption also leads to income. This is by expenditure method at the macro level. And at the micro level also, if you think, depending on my consumption level, I will try to get job, I will try to participate in the labor market so that I can maximize my consumption. Because if you think of, the individual is facing a particular utility function, where utility is, let us say, a function of consumption and the amount of leisure that I will take. So mode is the consumption, mode I will have the utility or satisfaction, and to get the minimum level of optimum level of consumption, I should have the optimum level of income as well. Okay, optimum level of income, which is, let us say, income star. So depending on, now this C star may vary from person to person. You may have a higher level of consumption for which you might be willing to participate in the labor market, you might be willing to supply more labor than me, because my demand for this consumption, my consumption is lower than yours, right, lower than yours. So depending on the individual's consumption, they will participate in the labor market, they will decide what type of job to take in the labor market, and they will also decide how much labor hours to supply in the labor market. We have already explained, these are all economic data. So that means what I am trying to say, consumption can also lead to income at both micro as well as macro level. So what type of econometric model you will specify? You will specify whether you will specify y equals to alpha plus beta xi or x equals to alpha plus beta y, that depends on your research objective. That is why it is the researcher, it is the econometrician, he himself or herself has to decide about the dependent and independent variable. Econometric analysis per se will not tell you what should be your dependent and independent variable. Okay. So once you specify the model, then you can establish, once you specify your dependent independent model, then you can actually establish the causal relationship, okay, by looking at the values of that beta hat, what you have estimated from your model, okay, what you have estimated. And then lastly we can use econometric models for forecasting as well. How will you use that? Suppose this is your consumption function, y equals to alpha plus beta xi plus ui, this is your model, and after estimation from the sample you have got this one. This is your estimated model. Now, how this could be used for forecasting for any particular year? Let us say I want to use this in 2018 data. Let us say this is my the macro consumption function that I have estimated, or let's say for a particular individual instead of 2018, let's say I would like to put the ith individuals, let's say xi equals to individual's income is 750 rupees. So, if you put 750 here, then you will get yi as 0.75 multiplied by 750. So, you will get the predicted consumption for the ith individual. Okay. So, this is how I can use the estimated econometric model to predict or forecast. Actually, forecasting, the term forecasting is used in a time series context, and prediction is used in both time series and cross sectional context. In this particular context, when you are using cross sectional data, we might be using the term prediction. So, when you have this yi hat equals to, let us say 0.50 plus 0.75 xi, then for a particular value of xi, you will get yi hat, okay, yi hat, and that will be your predicted value. And that predicted income, that predicted consumption, you can use for several other purposes, okay, several other purposes. Sometimes what we want to know, let's say I want to generate that level of income which will result in 750 rupees of consumption per week. Sorry, I want to generate that level of income that will generate let us say 1000 rupees of consumption per week. Why I want 1000 rupees consumption? Because sometimes policymakers might be interested in what should be the minimum income that the individuals must have, so that the individual is able to spend 1000 rupees weekly on different consumption items, rice, then dal, then oil, so on and so forth. Because we believe if the consumption bundle, if the consumer is able to buy that consumption bundle minimum, that will give you that much minimum calorie, so that satisfies individual's nutritional requirement. So, I want my individuals to consume 1000 rupees. So, what should be my level of income? So, that also you can easily estimate from this estimated equation. So, you can actually solve for xi. What is the value of xi when, let us say, yi hat equals to rupees 1000? That also you can do. So, two things you can do here. You can plug in any value of xi, and that will result in corresponding yi hat. If I put xi equals to 750, then basically you will get a corresponding yi hat value. That is a prediction. Given any value of xi, I can always predict the value of yi. Okay. When my objective is not to predict the value of yi given the value of xi, what I would like to derive, let us say, what should be my corresponding xi value, so that my predicted consumption is 1000 rupees. Because with 1000 rupees minimum income, what should be my minimum consumption, what should be the value of xi, so that the consumer can spend minimum 1000 rupees, because this minimum 1000 rupees will help, is required to buy that consumption bundle that will give the minimum nutritional value. This is how sometimes the poverty line is defined by the policymakers. Policymakers, they know this 1000 rupees consumption is required. Now, to sustain the 1000 rupees consumption, what should be my level of income? Whether the existing level of income is enough, or whether additional support to be given. Okay, support to be given. For example, let us say if the 1000 rupees consumption requires, let us say 1500 rupees income, okay, income. So, then policymaker will decide how many individuals are actually having this 1500 income on weekly basis. Okay. So, this 1500 rupees income if they are not having, then government has to provide external support. So, this is one utilization of how you will use this model, econometric model, for prediction and for forecasting. Forecasting is a time series phenomenon, as I said, that let us say this is a time series data collected from several years of GDP, and let us say GDP, your consumption is a function of let us say GDP, and you plug in any year's value on xi, okay. Given the value of xi, you will get your total consumption expenditure of the country or state. So, if you have time series data for any particular year, you put your xi, you will get your yi hat, okay, yi hat. So, that means you can also use this estimated econometric model for forecasting. So, that means with this we have completed our discussion on the objectives of an econometric analysis. Firstly, drawing inference about the population, specifically drawing inferences about the population parameter alpha and beta with the sample statistic alpha hat and beta hat, and then estimating a causal relationship between the dependent and independent variable. How will you get the relationship? Depending on whether the coefficient of the independent variable, here beta is the coefficient of income. Depending on whether the beta is statistically significant or not, we will establish whether income actually is causing consumption or not. How will you check the statistical significance? That we will discuss in a later part of our discussion. So, for the timing, just keep in mind that testing causal relationship basically comes from checking the significance of the estimates of true population parameter beta, which is beta hat, and then forecasting. Once you estimate the model, you use any particular value of x, you will get a corresponding value of y. If it is a cross sectional data, we generally say prediction. If it is a time series data, at the macro level, you are trying to predict the consumption of a particular state or country, it is called forecasting. These are the three objectives of an econometric analysis.